All right, guys, are you ready? We are starting the unit that separates the men from the boys. You know what I'm saying? We're starting unit 9, which is infinite sequences series. This is going to be fun. You guys got to really be on top of your game for this, so make sure your brain is working in order. Everything's all good to go. Let's do this. Okay. First of all, you guys, I don't know how much you have seen factorials before. Okay? Factorials are these little exclamation points, and it doesn't mean a number is really, really happy. What it does is it multiplies that number times one below it, below it, below it, all the way down to 1. As an example, okay, 5 factorial is 5 times 4 times 3 times 2 times 1, which is 20 times 3 is 60 times 2 is 120. That's what 5 factorial is, okay? This button is on your calculator if you need to use it. Okay, so, for example, all right, n plus 2 factorial would be n plus 2. The next number down would be n plus 1. That would be n. That would be n minus 1, n minus 2, all the way until I get to 1. We're going to put dot, dot, dot. N factorial is n minus 1, n minus 2, all the way down until we get to 1. We use a lot of these in probability, like statistics type stuff, but I don't know how much of that you guys have done so far, so... Now look what happens. The 1 will cancel, the 2 will cancel, the 3 will cancel, all those terms will cancel. N minus 2, n minus 1, n. All that stuff cancels out. So the only thing that's left on the top here is n plus 2, n plus 1. Okay? So this is... All right, we simplify factorials. That was just something that you need to know to be able to do some of this. Okay. When you guys hear sequences and series, a sequence is a list of numbers. A series is when we sum them all together. Okay? You guys, this, just like I introduced a new symbol to you when we did integrals, I introduced you the integral symbol, right? This is a new symbol. We'll write it like that. It's called sigma. It's a Greek letter, okay? And we usually read it as summation. In math, it means it's the summation symbol. It means it's summing up a bunch of stuff, okay? So I don't know how much you guys have worked with this, but let's see. An infinite series can be represented as, so it's the summation of every term, first term, second term, third term, all the way up to the nth term, but n starts at 1 and goes to infinity. So just summing these up forever and ever and ever. All right? So here are some examples, okay? Write out the first 5 terms of this series. Okay, so start with n equals 1. And like my 5 terms, you guys, I'm going to use this. So you don't always have to write them out. I'm just going to this first time because I think it'll help you. Okay, so I'm going to do n equals 1, n equals 2, n equals 3, n equals 4, n equals 5. Okay, so my first term is actually going to be 1 over 1 plus 1. And then if it's a sequence, we write a comma, but this is a series, so we write a plus. That's 2 over 2 plus 1. And then it's 3 over 3 plus 1, 4 over 4 plus 1, 5 over 5 plus 1. Okay, so it's 1/2 plus 2/3 plus 3/4 plus 4/5 plus 5/6. And I could sum all of those up, and obviously I'm going to use a calculator to do that. I'm not going to sum that up by hand. Let me grab a calculator. Okay, when I summed all these up, I got 3.55. I could put that in a fraction form. It shows me a little bit better. And I get 71 over 20. Okay? So that's the sum of the first 5 terms of that series. Now, what we got to be good at is taking things and writing them in series form, okay? All right, here we go. Cool. You got to look at patterns and stuff. So in this, can you guys see the pattern here? And what about if I put like a 1 over there? So we know the pattern is 1 over. And then what's happening on the bottom? 1, 4, 9, 16, 25. If you recognize those numbers, those are all perfect squared. Okay, so it's 1 over n squared. So that would be the nth term that I could put over here, and then it would keep going if it were going to infinity. Okay? What about this one? Those are 3's all on the bottom, or on the top, I mean. Then on the bottom, let's see what's happening. Okay. This is going times 2, times 3, times 4, times 5, right? So the first term is just, let's see, n. The second term is n times 2. The third term is the previous term times 3. So we got to think about how we want to write this, okay? All right. What do you guys notice about these numbers? Well, okay, so let's see if I can explain this. This is a little harder to explain, but we saw 120 earlier. Do you guys remember up here? When we did, oh yeah, 5 factorial was 120, okay? So if it's 1 times 2 times 3 times 4 times 5, so, you know, the next one would be times 6, so it would be 6 times 5, 4, 3, 2, 1. So it's over n factorial. 1 factorial is 1, 2 factorial is 2, 3 factorial is 6. All right, and so this would go dot, dot, dot to 3 over n factorial, dot, dot, dot. Okay, sometimes it's kind of hard to see, but keep those numbers are ones you should recognize as factorial numbers. All right. Okay, now we want to write these in sigma notation. So we want to go, okay, from n equals 1, and because of the dot, 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 we have to go to infinity. All right, now this actually has kind of 2 separate things here. On the top, do you guys see it's just even numbers? So if n is 1 went to 2, 2 went to 4, 3 went to 6, does it make sense that that's just 2 times n? First term, second term, third term, fourth term. Okay? On the bottom, these are odd numbers. Now, when you're writing even numbers, you do 2n. When you're writing odd numbers, a lot of times, odds are also apart by 2 because it's adding 2 every time. But it's not 2n. The way you make it work is you go 2n. This is for evens. You could use 2n plus 1 or 2n minus 1 will generate the odds. How do I decide which one I want to do? Well, remember, down here, I'm starting at 1. And so at 1, I want to get 1 when I plug in 1. Which of these, when I plug in 1, will I get 1? This one, my first term would be 3. This one, my first term would be 1. So that would be over 2n minus 1. So I would generate the evens on the top. That would generate the odds on the bottom. Okay? All right, let's look at this next one. Okay, so let's see what's happening every time. That one I'm multiplying by 3, by 3, by 3 every time. This one, though, multiplies by, well, it's alternating. So it's actually multiplying by -3 every time. Okay, this is a special sequence. This is called geometric. A geometric sequence starts with a certain number, and then it multiplies by r every time. And the way that we write a geometric sequence is it's whatever number we start with, and then it's r to the n. So the first, second, third, fourth, like that. Okay? So this one, it starts at 2, and I multiply by -3 every time. Okay? Now, that was not a good sigma. Okay? From n equals 1. Now, right now, if I plug in n equals 1, or rn or whatever, if I plug in n equals 1, I would get -6 for my first term, and that's my second term. So what could I do in order to do that? Well, one thing I could do, there's 2 ways to fix this, okay? Because that's my second term. I could either start at 0, and if I start at 0, 2 times -3 to the 0 gives me 2. 2 times -3 to the 1 gives me -6. And it would go off like that. So I could change my starting point to 0. Or you guys, I could leave this as 1 and write that as n minus 1. Okay? So those are two different ways to do it. You could either do that, or you could do n equals 0 to infinity, negative 3 to the n. Okay, and those answers are identical, so I just have to make sure that I'm careful when I grade your work and see if you started at 0 or if you started at 1. All right? Okay, so what happens if we add more and more terms to a series like this, 2n plus 1? Talk about 2n plus 1 is just the odds. So 1, 3, 5, 7, 9, 11, 13, 15, right? What's happening to that sum? So a sequence of partial sums. Okay, the way that we do that is we go like this. What's the sum of the first number? Okay, so just the first number is 1. What's the sum of the first two numbers? So if I added those, 1 plus 3 is 4. What's the sum of the first three numbers? 1 plus 3 plus 5 is 9. What's the sum of the first four numbers? 1, 3, 5 plus 7 is 16. You might notice those are the perfect squares. I don't know if you guys ever noticed this, but when you sum up a bunch of odd numbers, you will get the perfect squares. Kind of cool. The sum of the first five numbers, 1, 3, 5, 7, and 9, is 25, and it keeps going. So what is happening to those sums? Do you guys see that as I'm going, these sums are getting bigger and bigger? And they just keep growing, right? Off into the infinities. So this sequence of partial sums is approaching infinity. So it just keeps getting bigger until we're adding these like infinitely large odd numbers, right? When this happens, we call this series Divergent. Now, ever since the book series came out about Divergent, which is a very good book, or like people talking about neurodivergence and all that. You know, before that, we didn't really use the word divergent too much. Now we see it a lot, but divergent just means it goes like way off and it just it's like an exploding series. It just explodes. Boom. That's divergent. Okay. Now let's look at this next one. Let's list out a few terms. Okay. So when n equals 1, it would be 3/10. When n equals 2, it would be 3/100. When n equals 3, it would be 3/1000. When n equals 4, it would be 3/10,000. ... Okay? Now, I'm going to write those in decimal form so you guys can see this. That's 0.3, 0.03, 0.003, sorry, 003, 0.0003, okay? And the sum of the first number is 0.3. The sum of the first two numbers, so we're talking about here and here, 0.33. The sum of the first three numbers, 1, 2, 3, is 0.333. The sum of the first four numbers here is 0.3333. So do you guys have a guess as to what the sum of an infinite amount of these would be? Would it not just eventually go to infinity? The sum would go to 1/3 because it would just be 0.333 repeating forever and ever and ever. Okay? This is a series that we say converges because we'll end up adding smaller things till eventually it's so small it's what we call negligible. You're not really like adding anything else, and it converges to the number 1/3. All right? So that's kind of just a divergent series. It gets bigger and bigger, and a convergent series, it gets smaller and smaller and converges onto a single number. Okay, so let's talk about geometric series for just a minute. Let's see. All right, so we kind of talked about this a little bit, you guys, but basically we start with a, and that kind of becomes our first term, and then it's whatever we're multiplying to the n, right? So this is the general form of a geometric series. So it's when it's r to the first, I multiply by 1r. When it's r squared, I multiply by 2r. So when it's r to the n, I multiply by nr's, and I just keep going forever and ever. All right? Now, here's how this works. Okay, actually, let's jump to this next page. It's possible to find the sum even though it has infinitely many terms. Okay? So let's see here. All right, check it out. if the sum of all the terms is AR squared, AR to the third, dot, 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 all the way, it keeps going, right? If I multiply everything by R, then that becomes AR, that becomes AR squared, that one, that becomes AR to the third, and it keeps going. All right? Does that make sense? So it kind of just gets rid of the first term, but otherwise, it's the exact same sequence. We'll put AR to the fourth, and it keeps going. Now, what is S? That's this one. Minus RS. That's this one. Well, guys, when I subtract these, all those terms are going to cancel out together, and so it just equals A, right? S minus RS just equals A. And if I factor out an S, I get an A. If I factor out S, I get a 1 minus R equals A, and I can solve it. Okay, if you've ever done an infinite, like if you ever worked with sequences series before, you'll kind of recognize that formula. If not, that's okay. We still want to know this formula though. That's the sum of an infinite number of series. Let's look, for example, though, at like the question that we did before, which was this 3 tenths, 3 100ths, 3 1,000ths. Do you guys see that the first term was 3 tenths? And what was it doing every time? Multiplying by 1/10. Which is why I went to 300ths, 3 1,000th, 3 10,000th, right? That's what we call R. R is what we multiply every time, and it's 1/10. So look, the sum of that infinite series was my first term over 1 minus the ratio, which was my first term over, now 1 minus 1/10 is 9 tenths. And if I cancel out the tens, right, well, I'll do it this way. When I'm dividing by a fraction, it's the same as multiplying by the reciprocal. So I get 3/9 or 1/3. So the sum of that infinite series is 1/3, which we kind of figured out that if you keep adding a 0.3, 0.3, 0.3, it eventually goes to 1/3. Okay, that's how that formula works. Now, this is really important. This only works if the series converges. Okay, because if it diverges, in fact, if this goes like shooting off to infinity and this goes shooting off to infinity, mathematically, I just can't say that infinity minus infinity is 0. We know that. Infinity minus infinity is indeterminate. Okay, so we can't say that that is going to work. It's only going to work if the series converges. And how do we know if the series converges? Well, this series will converge every time it gets smaller. Every time that I make it get smaller. Now think about this. Okay, let's see. Let's start with the number 3. And let's multiply by, let's say R is 2. Yeah, I guess times 2 is 6, times 2 is 12, times 2 is 24, times 2 is 48. What's happening to that series? It diverges. Okay? Let's say R is 1. 3, 3, 3, 3, 3. That's just like weird. Does it diverge? Does it converge? I don't know. It's just the same number all the time. That's kind of a dumb case, right? Let's say that R is a third. 3 times a third is going to be 1. And then 1/3, 1/9, 1/27, 1/81. Right? That converges. So how do we decide if it converges or if it diverges? Well, look, if it's R is a big number, it's going to diverge. If R is a fraction, it's going to converge, because when I multiply by a fraction, it gets smaller and smaller. So when you're ever dealing with like sequences of series and you see this, it's going to be, well, okay, only if R is less than 1. But also if R is a fraction, it could be a negative fraction too, or bigger than -1. And at 1, I mean, I guess it doesn't really work at 1 because then you're dividing by 0, right? But that's just the case where it's like 3, 3, 3, 3, 3. So R has to be bigger than -1 or less than 1 for it to converge. And the way you'll usually see this written is the absolute value of R is less than 1. That tells me that the series converges, and I can use that formula. Okay, so that's just like a little bit of, so far we haven't done any calculus yet. That's just a little bit of like sequences and series front loading. All right. So we want to see if this converges or diverges. The first term, if n is 0, because r to the 0 is 1, so the first term is a, and then it will sum to a over 1 minus r only if it converges. All right, so let's determine if these converge or diverge, and if possible, let's find the sum. So let's look at this one. Right, every once in a while, it just helps me to write out a few terms. You don't have to, but just because we're new in this, I want to kind of do that. 3 over 2 to the 0, 3 over 2 to the 1, 3 over 2 to the 2, 3 over 2 to the 3. So this series is 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8. Right? So these are getting smaller. They look like those are converging. So my first term is 3. It's like 3 over 1, but my first term is 3. And what am I multiplying by every time? 1/2. Okay, every time you guys can see it's multiplying by another 2 on the bottom. So it's multiplying by 1/2. So this definitely converges because the absolute value of 1/2 is less than 1. And here's what it converges to. So the sum of this infinite series, even if we go out to infinity, it's a1 over 1 minus r. Just 3 over 1/2. And right when we divide by a fraction, it's like multiplying by the reciprocal. So this equals 6 if you sum this all the way out to infinity. Okay? And you can start summing this a little bit, you guys. You can, let me kind of show you how this works here. Okay, let me get this calculator app to pull up. And we can go like this. Come on, buddy. All right. Okay. 3 over 2 to the 0. 3 over 2. Oh, shoot. Dang it. I forgot I have to come back down. Sorry. Okay, there we go. Plus 3 over 2 to the 1. Darn it, I messed up my 2 to the 0. Oh my gosh, you guys. This is so hard to do with a stinking mouse. Okay. 3 over 2 to the 0. 3 over 2 to the 1. 3 over 2 to the 3. 3 over 2 to the 4. There's only the first 4 terms. And I'm already getting kind of close to 6. 3 over 2 to the 5. 3 over 2 to the 6. Okay. And we're just going to keep going until we get really close to our answer. So it's like 5.2. So I can keep going and it'll eventually get very, very close to 6. It's not growing very fast, but hopefully you guys, that makes sense. Okay. All right. So when I would sum up, whoops, sorry. Get out of there. Get out of there. When I sum up everything, it would give me 6. All right. Let me move this. Okay, let's try this one now. I'm going to write out a few terms, okay? 3 over 2 to the 0. 3 over 2 to the 1. 3 over 2 to the 2. So anything in the 0 is 1. That's 9/4. The next one would be 27/8, like that. Right? Now, A1, first term is 1. It's multiplying by 3 over 2 every time. Because that is a false statement, 3 over 2 is not smaller than 1. In fact, it's bigger. This thing's going to explode. So this is actually going to diverge. Okay, because the terms are just getting bigger and bigger. All right, now here's an example of we call these an alternating series. Because, okay, if I go 4, -1/2, wants me to start at 1 to the 1. Okay. 4, negative 1/2 to the 2. 4, negative 1/2 to the 3. 4, negative 1/2 to the 4, like that, right? 4 times negative 1/2 is negative 2. 4 times negative 1/2 squared is negative 1. 4 times negative an eighth is, oh, sorry, a negative squared is positive. Okay. Negative 1/8 times 4 is negative 1/2. So this actually goes back to negative. To the 4th is positive 1/4. And then it would go negative and then the next one. Okay. But if you think about it, so my first term is negative 2. That's right here. What am I multiplying by every time? I'm multiplying by negative 1/2. Well, since the absolute value of negative 1/2 is less than 1, that's true. Negative 1/2 is less than 1. This thing should converge. Okay, and here's how we tell if or when it converges. All right. So the sum as it converges would be A1 over 1 minus R. Okay. Minus a negative would be 3 over 2. So negative 2 times 2/3. So it adds up to negative 4/3. Why does it add up to a negative number? Well, because it starts with a pretty big negative 2. And then I add 1 to get negative 1. And then I go down to get negative 1/2. And then I add a 4th to get negative 1 1/4. And, you know, it just keeps on narrowing down to that one point. All right, so that one converges. Hopefully that makes sense. Okay, so guys, this is kind of fun. If I'm going to make a geometric series, find the fraction form of this decimal. Now, I could definitely put that in my calculator and see what decimal that is. Okay, but I'm going to do it with a series because it's so cool. Basically, this is 0.08 plus 0008 plus 0.000008. So every like 2 terms, I need to get one more on there, 0.008. Every 2 decimal places, it adds another 0.08. Okay, I can write this as a repeating series because so my first term is 0.08. Okay, so we call it like A1, that's my first term. And you guys, I'm multiplying by 1/100th every time. And I guess I'll start at 0, so that my first term is 0.08 to infinity, right? Well, that 1/100th is R. So the sum of all of that is A1, which is, it's 0.08. It's going to be easier for me to do this by hand if I do it. That's 8/100ths. And then it's 1 minus R, which is 1/100th. So it's 8/100ths divided by 99/100ths. And when I do a fraction divided by another fraction, I multiply by the reciprocal. So it's 8/99. All right, and we can see that on our calculator. If we just do 8/99, we get that as a repeating decimal. And let's see if it'll actually put it as a fraction for me. Okay, cool. All right, so that's how we can do repeating decimals as geometric series. Okay, we're going to show that this does not diverge. Or does not converge. Show a sequence of partial sums. Look, the first sum would be this, so that's 2. The second sum would be the first 2 terms, so that's 1, 2, that's like 3.5. The third term, 1, 2, 3, 4 plus 1/2 plus 1/3, which is like what, 4 1/6. So it's getting bigger every time, so it diverges. Okay, so this is pretty important right here, and this is our first limit test. And you guys, we're going to have a ton of tests that we have to memorize This is called the nth term test for divergence. Basically, it cannot converge unless it approaches a limit of 0. Okay, so if we have the limit as n approaches infinity, if it does not equal 0, it definitely diverges. If it does equal 0, we don't know. We don't know anything about it, okay? So look, what I'm going to do for my nth term test is say, all right, as this gets bigger and bigger and bigger, so n factorial over 2n factorial plus 1. Okay, so let's go ahead and take a look at this real quick. So we've got, well, you guys know as we approach infinity, that plus 1 isn't going to really make a difference. And it's kind of like the degree of the top and the degree of the bottom are the same. It sort of works like that. So the limit as I go to infinity is just 1/2, which is not 0. So we can say it's divergent by the nth term test. We will do a lot more questions like this in class.